Our assigned topic is sensational perception, which essentially deals with the processing of senses by the human body and mind. We conducted an article search, and we chose two specific studies that combined to form our research question.
In the first study, psychologists set out to measure whether speed of reaction to sensory stimulation is unchanged during movement. The short answer to that question is that yes, the speed of reaction to sensory stimulation is unchanged during movement. In order to arrive at their conclusion, the scientists in the study used basketball players who would have to catch and throw a basketball while a device on their wrist administered a pulse or an auditory signal. The basketball players would verbally acknowledge this pulse or auditory signal, and the scientists measured significantly fast responses in the movement groups compared to the control group.
In the second study, psychologists wanted to measure whether observation of own exploration movements impairs haptic spatial perception. In short, the two groups were instructed to use their hands to explore increasingly complex haptic stimuli. The difference between the experimental and control groups was a screen that prevented the participants from seeing their hands. Interestingly, the control group, who could see their own hands, made significantly more errors.
For our research question, we will somewhat combine the two studies to try to find out whether sports performance is affected positively or negatively by awareness of sensual perception. In sports, you often get the advice along the lines of not thinking about what you're doing, also known as just do it. We want to evaluate whether that's a good advice.
Now we will move on to the outline for our proposed study. To summarize, this experiment addresses the question of whether sports performance is affected positively or negatively by the awareness of sensational perception.
Participants. The participants of the study will be a random selection of 50 college-level male basketball players. We want to account as much as possible for any differences that may be due to experience, skill level, and potentially even gender.
Now we will move on to the procedure of the study. First, we will randomly assign our 50 basketball players to the test or control group so that groups are an even number, 25 players each. Second, one basketball player at a time will come onto the court with 3 researchers. Both groups will be told you will earn $10 for every shot you make as an incentive to perform well as simultaneously equalizing shot rates. Logically, everyone should shoot as quickly as they can. If in the control group, aka the no math questions group, the basketball player will be instructed to make as many free throws as possible in 2 minutes. We'll have ample ball carts lined up. One of the researchers will record the number of shot attempts and the shots made in the time period. One researcher will be in charge of making sure the ball carts flow smoothly as to not interrupt the basketball player. Finally, one researcher will sit off to the side, out of sight, and he will be used in the experimental group. If in the experimental group, the group with the math questions, the basketball player will be instructed to make as many free throws as possible in 2 minutes. The reasoning for the instructions is to control for taking time to answer and then shooting. Since we are measuring shooting accuracy, we needed a way to standardize the rate of shots without affecting other variables. In addition, the experimental group will be told if you don't get the math problem correct, a made shot won't count, although in reality it actually will count. One researcher will record, just like in the control group. One researcher will operate the ball carts, and one researcher will read a standardized list of simple math questions. Basketball players will shoot for the 2 minutes, and then they will be thanked for their effort and allowed to leave, and also paid for as many shots as they made.
Measures. Our dependent variable will be the percentage of shots made. We picked simple addition because it's seemingly simple enough to only require an automatic response from the brain. You don't think about 4 plus 2 equals 6, you just know it. We also think it's about the simplest math problem we could possibly ask, as addition is something kids start to learn in 1st grade. Furthermore, math requires a standard black and white response without any attached emotions or other factors. We considered simple conversation instead of math problems, but ultimately decided against it for the potential extra variables it could introduce. Some examples of math problems is 1 plus 2 equals 3, 1 plus 1 equals 2, 3 plus 2 equals 5, 5 plus 1 equals 6, and 3 plus 1 equals 4.
Now for our hypothesis and analysis. Based on our 2 studies cited above, we predict that the basketball players who answer math problems will make a higher percentage of free throws than those who don't have to answer the math problems. We predict that the math group will experience something of a sensation unawareness effect while their brain is occupied, allowing their automatic shooting ability to just do it. To test our hypothesis, we will compare the free throw percentage of our 2 groups of basketball players in addition to some statistical analysis to analyze significance of any difference between the 2 groups. Now for the discussion. The strengths of our study include easy replicability, easily quantifiable data, and we believe a low number of potential biases or extraneous factors. Our study can be replicated exactly with women, with inexperienced basketball players, or even a mixture of any or all of the groups. The data is essentially objective, leaving no room for interpretation no matter the researcher. We also believe we have done a good job controlling for biases and other outside factors, but then again, most people probably believe them, so we can't be sure.
Our study's main weakness is whether or not the math problems will be simple enough. Asking math problems is designed to occupy the brain without requiring real deliberate thinking to answer. 4 plus 2 equals 6 sounds like a pretty easy memorized response for most of us in the room right now, but it might not be so easy for the players. Our team considers simple addition easy enough to occupy the brain, yet not interfere in the same way that asking a player to explain quantum physics might. We want to occupy the brain just enough so that the players aren't thinking about their sensational perception when they're shooting.